Okay, guys, today we're going to look at activity series of metals. So these are going to be old school notes. You're just going to record these somewhere on a piece of paper, somewhere. You will need the textbook because this chart that's right here on my screen is on page 144 in your book. So you get after the notes, then you'll have a worksheet to do. So you'll need this chart. All right, so here we go. Metals. So these are all metals. We have lithium all the way down to gold here. The metals at the top of the chart are more likely to be oxidized or easily oxidized. So they go from no oxidation number, like this is 0, going to a positive 1. So it's losing an electron. So this is showing oxidation of reaction. So those on top, more likely to be oxidized. Those at the bottom are a little more stable, less likely to oxidize. If you look at just in terms of metals, not the ions. But this is kind of how you see if a reaction is going to take place or not. So you follow this. Metals on the list can be oxidized by ions of elements below it. So that means you're going to put a solid metal into a solution of an ionic compound that has a metal that's in ion form, and you're trying to figure out whether this reaction will occur or not, meaning they're going to go through a redox reaction. So we'll do a couple examples here. So it's pretty easy. Just got to kind of follow the example here. So here's my example. I have solid copper. I'm putting a solid piece of copper into some silver, I don't know, maybe silver nitrate solution, whatever it might be. But it's a silver ion that's floating around in the solution. So you're trying to see if copper is going to be oxidized and silver will be reduced back out again, like a kind of a plating situation occurring. So what you do is you find copper on the chart. So copper's right here. And then I find the silver, which I see that is right below it. So I can see the ion, the silver ion that's here, is below the solid copper. So I would say yes, this does occur. This reaction will occur. So you have a couple examples here. You can try them. You can pause and see if you can see them on the list and see if you're going to say yes or no. All right, so to check your work, you're going to put solid zinc, for this example, into nickel chloride solution. So you're looking at the solid zinc versus the nickel ion in the solution. So I find zinc on here, which is in green right up here. And then I find nickel right here. So the nickel ion sits below the solid zinc. So you would say, yes, this reaction would occur. And then I can write a single displacement reaction, put the zinc in with the chloride, and now nickel comes out, just like I did here in this example. Okay, then the last one, gold is reacting in an acid, hydrochloric acid. We're going to see if this is going to behave or not, if this is going to, go forward or not. So I find gold. Ooh, the gold's way down here. Pretty stable, not really going to react. And then I would look for the active part of this we're looking for is the hydrogen ion, because it's an acid. That's the active part of the acid is the hydrogen ion. So if I find that, I can see that's way up here above. So the hydrogen ion sits above the solid metal. So you would say no. This is why gold is good piece, like for jewelry, really good, because the acids on your hand and things like that, it won't react with, it won't start pitting out, and so it lasts for a long time. All right, so that's for metals, right? All right, now let's look at non-metals. So again, you should be writing some of this stuff down in your note or like somewhere on a piece of paper or somewhere. This is the activity series for non-metals. This is not in your book, but you kind of have to figure out whether they're going to be react or not. So the only non-metals we're looking at are like the halogens, right? So it kind of goes in order: fluorine, chlorine, bromine, iodine. So going up the chart, those are more reactive. So like fluorine will react with the bromine, and then if I have iodine's less reactive, fluorine's the most reactive. That's kind of how it works. They'll displace it. So if I have F2 going in with I negative, that's going to react. But if I have I2 going in with, I don't know, sodium fluoride or something like that, that's not going to react. That's where the thing works. All right, So you're gonna try that little half page and see what you come up with. Yeah, and then we'll check them next time. All right, good luck.